Last chapter we talked about confidence intervals. Now confidence intervals are kind of a big deal in statistics. Anytime you see a statistic, lots of times there's a plus or minus 2 percentage points or something like that. Now you might pay a little bit more attention to that now that you know all about that stuff. Okay, now let's go on to the next chapter, which is testing a claim. This guy over here, his name is Dan Meyer. I don't really know him, but I've seen him at a couple of math conferences. He's kind of a big deal in the math teacher community. Super awesome guy. He's actually working on his doctorate at Stanford for curriculum and instruction for mathematics. And here he is. He has figured out the equation to shoot a basket from the top of the key. Now he says that he's shooting with an 80% accuracy rate. Now we're going to test that claim. I think what's helpful in this chapter is if you think of yourself as an attorney, a prosecuting attorney. You're innocent until proven guilty. We never prove anybody innocent. We only prove them guilty. So what you're trying to do is they have a claim and you're trying to come up with statistical evidence that shows I am fairly certain that your claim is false. So you have two things. You have the null hypothesis and you have the alternative hypothesis. Now, the null hypothesis sometimes is referred to as everything is the same. In other words, there's no change. Their hypothesis is fine. We're not going to change it. So, and that's indicated by this, HO. Okay, that's the null hypothesis. And then the alternate hypothesis is what you would say is when you say, okay, I'm going to reject the null hypothesis and go with the alternative hypothesis based on this data and these statistics that I've come up with. Okay, null hypothesis, alternative hypothesis. So in this case, this is what we have. We have our null hypothesis, which is Dan says that he's an 80% free throw shooter. And our alternative hypothesis, that's what we want to gain evidence to prove, is that actually he's probably less than an 80% free throw shooter. Okay, null hypothesis, alternate hypothesis, alternative hypothesis. Okay, let's take a look at some statistics on this thing. Okay, can you see what happened here? Now p hat is a statistic, and a statistic comes from a sample. So it looks like we asked Dan to take 50 free throws, and he made 32 of them. Now, let's see, what is that? That is 64%. Quite a bit lower than 80%. But that's only one sample. It could have been just bad luck, and he really is an 80% free throw shooter. Or maybe the other thing is, maybe he's not 80%. Okay? Now, how do we test this? Well, maybe we have to take a bunch of samples. Okay, this is what happened, and this is in the book. They got a computer simulation where they simulated someone taking 50 shots who was truly at 80%, and they did it 400 times. And let's take a look at what that looks like. So here's our computer-generated data. 80% free throw shooting. Okay, what they did is they took 400 sets of 50 shots each, and they set this simulation up, and notice kind of a normal curve with our center right there at 80%. But notice this, there's only 3 sets of 50 out of 400 that were 32 or less. So if we say that it was just bad luck, well, it was extremely bad luck. The probability of that happening is 0.0075. Wow, that's amazingly bad luck. So what we would do is say, well, based on the fact that the probability that what happened is so low, we're going to go with the alternative hypothesis and say, you know what, I don't think that you're an 80% free throw shooter. So that value, that 0.0075, that is called the p-value. And so what that means is you take an observed piece of data, and you're going to compare it to your null hypothesis. Assuming that the null hypothesis is true, you say, well, what's the probability that that actually happens? The p-value, the probability that that observed thing actually happens, given that your null hypothesis is true. In this case, pretty low. Now here's another thing. How low does it have to be for us to reject the null hypothesis and go with the alternative hypothesis? Well, a lot of times when we do a statistical test like this, there's something called alpha. We write this down, statistically significant at level alpha of say 0.05, which means that if we come up with a p-value that is less than 0.05, then we reject the null hypothesis. And so typically we have two alpha levels. Usually it's 0.05 and 0.01. Okay, depending on how strict we want the test to be. Now, if somebody's life is on the line, if you're doing a medication, maybe you want to do a test on that medication. A lot of times we're going to say, okay, we're going to go with 0.01 because we want to be very sure. Okay, so that's kind of like a quick overview of statistical tests and testing a claim. We've got the null hypothesis, alternative hypothesis, the p-value, and the alpha level. Okay, now if you watch this video, I think it's going to be very helpful when we start class tomorrow morning. Okay, bye.